All right, let me take 5 minutes then and review with you guys motion. Because this unit really was about motion. And the idea was to get you to come up with two models in your head. If you already had the models, great. If you didn't, hopefully you came up with better ones. These two models are, what does it look like and mean when you have constant velocity? And the second one, what does it look like and what does it mean when you have constant acceleration? So we have a definition of velocity, change in position over change in time. Or in other words, it's how quickly your position is changing. Remember, velocity is different than speed, at least in one way, in that it includes a direction. There's another way, but we won't test on that much. So velocity is your speed plus your direction taken together. So 40 miles an hour to the north is not the same thing as 40 miles an hour to the east. Those are different. For units for this, most of the time we use meters per second, but remember there's that rule of thumb. If you have meters per second and you double it and add a little extra, you will get miles per hour. So that's one that you'll need to make sure you know. For constant velocity, when we did a motion map, that would look like even spacing. When we did a position time graph, that would look like a constant slope. It could also be downhill. It didn't have to be that way. Something like that. When we did a velocity time graph, that meant the velocity was staying the same. So it was something like this, or it could be a line down here too. So the height would stay the same, in other words, on that. So that was constant velocity. Most people, I think, had a pretty decent model of that in their head before we started anything. The constant acceleration part was a little bit new for most people. Definition of acceleration is it's how quickly your velocity is changing. There are three ways to change velocity. Speed up, which most people already recognized. Slow down, which is sort of new. And change directions or turn, which was definitely new. Because turning is a way to change your velocity, so that's a way to accelerate. Remember, our definition of acceleration is a little bit different than the street definition. So what that would look like with a motion map would be the spacing would somehow be changing, getting bigger, smaller, or whatever, or turning. Position time graph, we'd have to have a change in the steepness. So maybe a curve, upward, could have been a curve upward but kind of getting less steep, or you could have had a bend, which was a change in direction. For the velocity time graphs, it simply meant that you were somehow changing the height of things, going up, going down, dropping to zero, whatever. So those were the three ways that we could visualize what acceleration really is. The last piece really that we talked about is two other formulas. Shortcuts for finding how fast something is moving if it's been accelerating for a certain time, and also how far it's been going or how far it's fallen if it's accelerated for a certain time. Remember, those only work when you start or end from zero or at zero. We also, though, had the think it through method, which is basically find the average speed that something's moving while it's accelerating, multiply it by the time, and that would give you the distance that it's traveled. Even though we know it's not really going that speed the whole time, but that average will give you the right answer. So that's what I call the think it through method. And that is basically the concepts. Now let's talk about the test real quick. The test will be made up of 20 multiple choice questions, and then 5 questions that make you apply what you've learned. These will make up the front page of the test. So I'll hand grade these guys right here. This will be graded by Scantron. So you do need a number 2 pencil. The application problems might be you have to draw a graph, you have to do a motion map, you have to do some calculations, you have to explain, something like that. As an example, let me just show you this particular test I used to give in a different unit, energy. The front page here you can see is they have to draw some stuff. You haven't learned this yet, but they had to draw some stuff. They had to figure out some numbers using some math equations. And then they had to explain something at the bottom. So your front page will be something similar to that. They then had multiple choice, which is just like kind of normal multiple choice questions, where they'll take the answers here and mark them on their test, but also bubble them on the Scantron at the same time. So you have both parts there. Write your answers on the test and the Scantron. Any questions on that?